All right, our very first speaker today, everyone says, "Hi, Dom." So this is Dominic Farolino. He's a software engineer at Google on the Chrome team. So he is basically Dom working on Dom Center at a company that dominates tech industry. I could be Dr. Seuss if I want to. So he has worked on Chrome, Firefox, and at Microsoft. He's collecting browser experience like he's Thanos. And Dom is a runner, he's a track star. He's a former juggler. I actually was going to bring some balls and see if you can still do it.
No, the answer is no. Former is correct.
Okay, that's why I say former juggler. And he's here to talk about Observable API. Without further ado, Dom.
Awesome. OK, thanks so much for joining me for the first talk of the day. I'm super excited to talk about this new primitive that I'm trying to work on bringing to the web platform called the Observable API. But before we get started, let's get to know each other, or at least you can get to know me. As Daphne said, I'm Dominic Farolino. I actually go by Dom, but I introduce myself as Dominic, because I find that if I say Dom Farolino, people think I either say Don Farolino or Tom Farolino. It's always wrong. It's never the right thing. So I just keep it easy. But yeah, I'm Dominic Farolino. You can feel free to pull out your smartphones or your flip phones or your Abacus and follow me on either Twitter or GitHub or something. I usually post about web APIs that I'm excited in or involved with myself. As Daphne mentioned, I'm a software engineer on the Chrome team at Google. I work on the web platform. I work mostly on DOM APIs for legal reasons, because of my name. That's a joke. Also for legal reasons. But I also work on a lot of web standards in the What Working Group standards organization, if you're familiar with that. OK, so what is this talk? We're going to be talking about observables. But in order to really dive into observables, we first have to give a brief overview of just what async means on the web platform. Then we can talk about what an observable is and how the guts of observables work under the hood. And throughout the talk, we're going to see a ton of examples of observables in action and how to use them and all kinds of stuff. And then the last two bits are really important. We're going to talk about how to unlock the full power of this primitive through operators on the Observable API. These are just fancy words for methods on the Observable API. And then finally, we're going to talk about disposing of resources and unsubscription and so on. So let's get started. To talk about async on the web, we first have to talk about promises and callbacks. So JavaScript is a normal language. It executes from top to bottom. You can use the result of a bunch of async work as early as the next line of code. But things get a little more hairy when you do async work. When you schedule some async code, you don't get access to that async value, and you can't use it on the next line of code. So JavaScript solves this by allowing you to pass in callbacks. And the callback is what runs sometime in the future when the result of that async work is available. But the problem with this is that you have to stuff any of the program that depends on that value like inside this new callback function, which is kind of annoying and kind of tedious. It breaks up your program, and it gives you this really non-linear control flow, which is unfortunate. And this is all a result of this leads to what we call callback hell in JavaScript, right? When you have an async value that depends on an async value that depends on an async value, until finally you can do the thing you actually want to do inside. And this is all the result of, for a long time, JavaScript never had a synchronously available handle that represented async work. This was, of course, until promises, which allowed us to write code like this. We can immediately get access to this value that is returned from the result of scheduling async work, and then we can immediately call methods on it like .then and pass in a callback that produces the value. But we're still dealing with callbacks, so it doesn't feel like we're really out of the woods yet. But the magic with promises is that, of course, each then handler returns a promise. So if we want an async value based on an async value and so on, we can chain these together and mostly reclaim our linear control flow. And this is great, but the problem is we can't do this with events and event handling on the web yet. Right? Promises are awesome. We love them. We use them every day. But they have some limitations. The first one is that they're single shot. Right? They're one shot. They only produce a single value at a time, and then they're done forever. So if you have a promise that represents the click events fired at an element, for example, your promise is only going to be able to emit a single click event one time, because the resolve function can only be called once. And that's an issue with events. Usually you have an arbitrary stream of asynchronous events that you have to process. But the second limitation is that they have forced scheduling inside. So if we go back, and maybe you're okay with having just the first click event, and that's what you can deal with, and you can call .then on that promise and handle the event accordingly. The issue with promises is that by the time that callback actually runs, by the time you get access to that value, it's already too late to do a lot with it. I mean, you can print it, and you can introspect some of the values and so on, but you can't do a bunch of things like prevent the default behavior of the event and manipulate its flow as it gets dispatched throughout the DOM. And that's because this always runs asynchronously after the event is fired. So the result of this is promises are not really a good partner or API with event targets on the web platform, which means we're stuck with basically the old school APIs on event target, like addEventListener and removeEventListener and so on. And this gives us into like a version of callback hell, which I call addEventListener hell. And we're going to show you an example of this in action. Maybe you probably know what the Konami code is. This is like an old cheat code injected into like a lot of old Japanese video games and so on. The pattern's probably pretty recognizable, like up, up, down, down. I mean, you got it. It's right there. So imagine you wanted to make a website that listened for the user typing in the Konami code, right? You'd probably write some code that looks like this. It's a little messy, so we'll step through it line by line. The first thing you're going to do is just add an event listener for key down events on the page. But only one time, because we just need to see if the very first key pressed matches the first key in the actual Konami pattern in this case. If so, we can continue. We'll create a new handler for every subsequent key press, and immediately add it to the document as the new event handler. And this handler needs to tear itself down and basically destroy itself in two scenarios. The first is if the pattern ever stops matching, if the user types in something wrong. And the second is if the user has only typed in right things the whole time, and we get to the end, we can log a success message and then be done. This isn't terrible, but you can see for such a simple example, we have 3 nested calls to event listener APIs. If you forget any one of them, you either get a memory error, or sorry, a memory leak or a logic error or something like that. It's real fragile. So I'm here to tell you that observables, this new reactive primitive that we're working on bringing to the platform, will save the day for examples like this. But first we have to know what an observable actually is, okay? So observables are kind of like promises for multiple values. That's roughly correct, I mean, but that's the scaffolding I want you to have in your brain for now. But there's 2 big takeaways with the API. The first is that they are the synchronously available handle that represents an arbitrary stream of events that can be dispatched at any time. And you can immediately manipulate future events in this stream with the powerful operators that come on this API. But the main takeaway here is that observables were designed with event target integration in mind. And so a snippet from our spec looks like this. We're actually introducing a new method to the event target interface that returns an observable. It looks kind of like addEventListener. It takes an event type, but it doesn't take a callback. It just returns an observable. Now, in this snippet, we're calling the method on, but I have some terrible news for everybody in the community. There's probably a really good chance that, like, literally maybe today, we're going to have to rename this API to something else that doesn't conflict with a bunch of libraries that we're going to break if we ship this in Chrome and in other browsers. And the on method was the reason I got in this game in the first place. So I'm pretty bummed. We're going to host calling hours and a service after the session to mourn the loss of this API. So we could just take a moment of silence for that. But anyways, whatever the API is called, you'll see on in this talk. But its intention is to be a better addEventListener. And we'll show you some examples. So you can use the on method in this example to get an observable that represents the stream of all click events that can be fired at this element. Now, you probably don't want every single click event, so maybe you want to filter some of them out. This is where the observable operators that we're going to cover later come in. You can call filter, which gives you a chance to pass in some filtering criteria. But the powerful thing about this is that the operator here, in this case, returns an observable itself. So you can call other operators on it, like map, which allows you to, in this case, map the event object into like a bare bones object with just an x and y for the click coordinates in this case. And that also returns an observable, which means you can call sort of like the master function on this at the very end called subscribe, which lets you pass in a callback and process the event accordingly. So you get this nice linear declarative flow that the events, whenever they come in, will flow through, and you don't have to deal with a lot of nesting and a lot of manual teardowns and so on. So eventually someone clicks on the element, an event gets created, it goes through the filter, and as long as it passes the filter, it'll only then go to the next operator, map, in this case just, again, maps it to a straightforward bare bones object, and then it finally goes to your subscribe handler. You only get the mapped and filtered out values that you wanted at the very end of the pipeline. So now let's figure out how we can fix the Konami example with observables. So you can imagine we'd want an observable that represents the stream of all key down events. But we don't care about the events themselves, we really just care about their event names, so we can just map the useful information out of them. And we don't want every key down event, we probably just want 10 or 12 or however long our pattern is. So we'll just take the first n number of them. And we can use other operators to check that every key pressed has an index that matches the key in the corresponding pattern, and so on. And then at the end of all that, we can get a signal as to whether they all matched or not, and we can log a success or an error message accordingly. And it's much simpler. We don't have to deal with nested remove or nested add event listeners. It tears down itself. It's really easy to audit to make sure it's right. And that's what we're working on introducing here. So that's a brief example of an observable in action. I want to talk about how they work under the hood and how you can make your own. So I told you observables are like promises. And promises have like producer and consumer code. Right? The producer code is the callback function that goes into the constructor. It gets this resolve function, and you can call it, in this case, with the value 10, and the consumer in the .then handler gets access to it. Observables are very similar. The producer code also goes in the constructor, but they don't get a resolve function. They get this subscriber object. And they don't call .then, but they call something else called .subscribe, of course, after you use this API. So with your subscriber object, you can call the next API to push arbitrary numbers of values through the consumer, which uses a subscribe function. Looks really similar to promises, but there's some key differences here, which we'll cover in a bit. But the first difference is this next method, right? It's kind of like resolve for functions, but for promises, but you can call it an arbitrary number of times to push values. But what other APIs on the subscriber object do we have access to? Here's a snippet of the subscriber interface in our observable spec that we've been working on for about a year now. Like I mentioned, we have the next method, which is kind of like resolve, but you can call it many times. We've got error, which is like reject, and we've got complete, which tells the consumer we're never going to call next again. This is a more elaborated version of how observables can look. You can pass in a single callback, or you can pass in an object that has corresponding named callbacks for the next, the error, and the complete handlers on the subscriber object as well. So this is sort of the full version of that. But there's a huge difference between promises and observables that's been right under our nose the whole time, and it's the fact that observables are lazy. This is in contrast with promises being eager, and what I mean by that is when you construct a promise, that callback runs immediately. The promise is already on its way to resolving or rejecting before you even have a consumer. And observables are the exact opposite. This callback function doesn't run right away. In fact, it only runs once you subscribe to the observable with the subscribe method. And this is in part because observables are multicast. So you can actually call subscribe an arbitrary number of times and invoke that function and get basically a new subscription for every single time you call the observable. And so just to kind of recap what we're seeing so far, this is roughly what we have, the difference between promises and observables so far. Observables can emit many values, they're lazy, and that is due to, in part, them being multicast, whereas promises have a single consumer and a single producer at any given time. I want to just walk through an example of a native event listening observable in action. So imagine you've got some HTML, you just have a simple button. Under the hood, the browser is going to maintain this event listener map. It's basically a map of event types to registered listeners that can handle events of that type. Now imagine in JavaScript, you create an observable that represents all click events that can be fired on the button. What this is going to do in like the C++ or Rust or whatever in your browser is it's going to create an observable object under the hood in native code. And observables are created with producer functions, so it has to have a producer function. This is going to be like in C++, but I'll show you the JavaScript equivalent of what the producer is going to do. Basically, all it's going to do under the hood is whenever it's subscribed to, it's going to add an event listener, and it's going to forward every event to the subscriber. It's an ergonomics thing at this point. So eventually, you're going to want to subscribe to that observable. You actually want to start handling click events that get fired on the button. So you'll call subscribe, and you'll pass in a next handler. And again, that's going to execute that callback function. It's going to add an event listener inside the event listener map. And that's going to set up the rest of the pipeline through which all click events will flow. Some point later on, someone's going to come by, click the button. That's going to generate a new event. It's going to go through the map. It's going to find that the registered event listener is actually the observable. And the observable callback, as we had written, is just going to get forwarded straight to the subscriber, goes to the next handler, and in this case, it just gets logged. So at this point, it seems really similar to addEventListener. The key takeaway here is that this is all synchronous. Unlike promises, there's no asynchronicity built in. So in the same, when we log the event in this case, we're in the same exact call stack as we are when the event is dispatched. So we can call, prevent default and stop immediate propagation and all the other APIs that can influence the flow of the event. And that is one of the key differences between observables and promises, is the scheduling. Promises have this built-in microtask asynchronous checkpoint, whereas observables are fully synchronous. You can build in scheduling if you want, but it's not there by default. Okay, so the last two pieces of this talk are really important. You saw me in a few examples use a bunch of operators, right? Like filter and map and take and so on. And I want to talk about where these actually came from and how they can really help you unlock the full power of this primitive. So the list of operators that we decided to include initially with the observable proposal for the web platform is derived from TC39's iterator helpers proposal. This is basically a JavaScript language spec that says, hey, anything that's iterable, anything that can be run over with a for loop, should have these APIs implemented natively by the engine under the hood. So any array or anything that implements the iterator protocol can be mappable and filterable, and you can take the first n values and so on. This allows you to, without having to worry about where these methods actually live, you can just call map and map values to their doubles, or filter even values out, or do more complicated things, even like flat map. Flat map, if you're not super familiar with it, flat map basically allows you to take a single value and map it to a collection of values, in this case, another iterable. And flat map under the hood is responsible for flattening that out into individual values, which is how we map 1 to 3 values based on 1, 2 to 3 values based on 2, and so on for 3. Now I want to show you how this looks and how these operators work under the hood in observable land. I think that's for me. Can I grab that? So here's a quick example of an observable pipeline with some operators. We've got some code gaps here. We're going to fill that in a bit. But first things first, we have an observable at the top. So let's just say it's responsible for emitting arbitrary whole numbers throughout its lifetime, just asynchronously whenever. First thing we're going to do is filter the even ones out, and we're going to call flatmap. So when we called flatmap on values in an array, that turned individual values into an array. With observables, we're going to turn an individual value into an observable that emits more individual values. That could go on forever, like literally. So we're only going to stipulate, we just want 6. We're just going to call take 6, and then we want to subscribe to the first 6 of these numbers. So let's see what happens. The first number will come in from the observable. It's subject to the filter. It's not even, it's odd. And in this case, it passes the filter. It goes down to flat map. And again, flat map, in this case, we're going to derive a brand new observable that just asynchronously, whenever, takes 3 values based on 1 and emits those. So that 1 becomes an observable with 3 values. And maybe later on, in some idle time, the first one of those is emitted. It goes through the take operator, which ensures that we only take 6. We're not at our limit yet, so we can log it safely. Let's say before 1.1, the second value gets emitted, though. A second value comes in from the outer observable. It fails the filter, so we just drop it dead here. And then maybe later the second value is processed, and it gets logged to the console, and so on. But before the last value, maybe we've got a third value that comes in, and it's actually odd, my gosh. So it passes the filter, and it's going to go to flat map, but notice we're not actually done processing values in that inner observable quite yet. So we're going to put that number 3 on ice, and we're going to wait till asynchronously later that observable emits its final value. It goes through, gets logged, and notice the call to complete. It completes itself, telling flat map to move it out of the way and make room for the next queued value. And then the next observable is processed. In this case, we'll just put all 3 values right through the logger. And the only thing that is special here is that when that third value goes through and finally gets processed by the subscriber, take knows how to complete itself, basically, under the hood, which is going to tell the original producer, hey, stop producing values, I don't care anymore. And it's also going to fire our complete handler. So that's just a rough example of some of the operators and how you can use them with asynchronous streams of events and observables. We have a full list of operators in our spec. Some of them return observables, some of them return promises, and this screenshot's almost certainly out of date, so you should check out our spec, which there'll be a link to at the end for the latest. The final thing I want to talk about is resource disposal and teardown and unsubscription. So you can imagine an observable that every single second it just emits a value until the inevitable heat death of the universe or until your power dies or something. You probably want to subscribe to these values, but probably not all of them. Maybe you just care about the first 100 or so. And so you have this code that basically is dead code for every value after the 100th. And that's really wasteful because the observable is just not going to stop producing values. So we need a way to signal from the consumer to the producer, hey, please, I don't care about any values anymore. Stop sending them. So the first thing we need to do is set the producer up to tear itself down. We're going to get the token returned from setInterval, and we're going to use the addTeardown method to say, all right, consumer, when you want to signal to me that you're done, I'm going to clear the interval and stop producing values. And so that's half of the equation. Now we just need the consumer to tell the producer how to do that. And on the web platform, this kind of signaling mechanism is usually with an abort controller and abort signal. So inside that dead code, we're just going to abort this new abort controller. And the key to actually wiring this up with the producer is by subscribing with that controller's signal. So that eventually in the future, when we do call abort on the controller, when we're no longer interested in values, the producer knows how to tear itself down. That's the kind of the verbose way of doing it. So I want to talk about these terminating operators that make that a lot easier. Things like take and take until and first. So here's that same exact observable, but if you don't want to write all that verbose code, you don't have to subscribe directly to that observable. You can subscribe to an intermediate observable, in this case, the take 100 observable. When you subscribe to it, it actually just subscribes to the original source, but it uses that whole signal mechanism under the hood so that in the future, when the 100th value is hit, it actually knows how to cancel itself, tear itself down, tell the producer to stop, and then fires any complete handlers that you might have passed in. And that's kind of how these terminating operators make it super simple to tear down without having nested functions and so on. All right, so we made it pretty much to the end. That's basically all I've got to share when it comes to the Observable API. The last thing I'd like to do is leave you with a request for some engagement. We've got this GitHub repository that we've been working on the observable spec and the Observable API. We've had tons of super awesome engagement with the community, and so we would love for you to reach out and tell us, where we're wrong and what use cases we're missing and what operators you might think are super critical to include so we can get this right the first time. The last thing I'll say is that we also have an experimental implementation of observables inside Chrome. You can actually flip this flag on and run all the code examples inside our repository. And this repository has been worked on by myself, as well as Ben Lesh, who's the almost sole maintainer of RxJS, the most popular userland observable library in JavaScript. That's pretty much it. If you want to follow along the progress of this API and so on, I would really encourage you to come and follow me on Twitter. I post about this kind of stuff, as well as other APIs a lot. We'd love to get more engagement and to have the developers get really hyped up about this primitive that we're basically trying to use to make addEventListener extinct forever. At least that's my personal goal. So with that said, thank you very much for listening. Appreciate it.